All right, the concept I need to introduce you guys to today is the concept of measuring angles in radians rather than in degrees. So you may or may not be familiar with this already, but degrees are not the only way to measure an angle. We also can use radians. All right, and I'm going to show you how to convert between degrees and radians. But first, I want to explain to you what radian measure actually is. We all know that the radius of a circle is just the distance from the center of the circle straight to the outer edge of that circle, right, to the perimeter. So if I were to take that radius that I just drew and peel it off the page so that I'm holding it in my hand, and then lay it down along the edge of this circle, it would take up about that much, right? So this is about the space that radius would take up. This is an estimate, okay? So if I peel this radius off the page and then lay it down along the edge of this circle, there it is sitting there. And then let's say I have another one too. So that one's sitting there, and then I lay another one down. So here comes the second radius, and it takes up maybe that much space. All right, so now what I have is I have one radius sitting there, and I have a second radius sitting there. And I'm going to keep doing this. I'm going to lay down one more radius, and maybe it takes about that much space. I'm probably underestimating it a little bit. But now you can see that I've got one radius, two radius, three radius, and there is a little bit extra here. And this little bit extra turns out to be 0.14159, and that is a long irrational number that goes on forever and ever and ever. So what this means is, if I take a radius off the page and I duplicate it many times, then it will require exactly 3.14159, long repeating decimal, of these radians or radii to fit along this edge and to cover half of the circle. And we all know that in degrees, that would require 180 degrees. So in degrees, I could go 180. But in radians, that would be 3.14159 radians, right? And we know that the number 3.14159 is pi. So that's why this number pi is so useful when we deal with circles, because it is exactly the number of times that the radius of any circle fits along the edge of that circle around the circumference to cover half of the circumference of the circle. All right? So with that being said, it should stand to reason that if I continued this, finish laying that one down, and then lay down a couple more of these, we're going to realize that to cover the rest of this circle, it's going to be 360 degrees or 2 pi, right? We're going to need a whole nother pi number of radians to cover the second half of this circle. So in degrees, we have 180, and in radians, we have pi. And that's a pretty important place to start. So we're going to start with this distinction. Pi radians is 180 degrees. And we're going to go from there. Let's think about some other easy angles, like 90 degrees. Well, if 180 degrees is pi radians, and 90 is half of 180, then the number of radians would be half of pi. So what we would say is 90 degrees is pi over 2 radians. All right, and we're going to start to convert between some angles that are a little bit more difficult using this. So 90 degrees is pretty easy. All I have to do is divide by 2, because 90 is half of 180. 360 degrees is pretty easy, because all I need to do is multiply by 2, because 180 times 2 is 360. But what if we were dealing with, for example, 150 degrees? And maybe I wanted to turn that into a radian measure. Well, what I'm going to do is I'm just going to use what we know. We know, and I'll just use this fraction as a guide. This is my guide for how I'm going to set up my proportion. We know that pi radians is equal to 180 degrees. So the question is, how many radians is 150 degrees, right? This is a proportion. This is a proportion just like we were using when we were transforming our special right triangles. And we can use this to figure out how many radians 150 degrees would be, because we know enough about this relationship to make a comparison there. So what I would do is I would multiply both sides by 150, 150, 150. That's going to allow these to cancel. And now I'm going to have 150 pi over 180 equals x. So there it is. That's how many radians 150 degrees would equal. I want to reduce that a little bit, so I'm going to divide each of these numbers by 30, and then that's going to give me 5 pi over 6. So if I want to know how many radians, or the number of radii that I would need to go 150 degrees around the edge of the circle, it would require 5 pi over 6 of those radii. What I'm going to ask you guys to do is, before you come into class tomorrow, I want you guys to take this concept, use that proportion, and complete A. I've already done a couple of them for you. We know that 360 degrees ends up being 2 pi. I'll show you that using our proportion. I know that pi is to 180, and that's always going to be our first fraction, as something is to 360. So again, I would just multiply by 360, multiply by 360. This side would cancel, and then I would have 360 pi over 180, which we know would reduce, because 360 divided by 180 is just 2. So I would end up getting 2 pi. Same thing with 90. X over 1, sorry, not x. We're going to start with the relationship that we know, which is that pi is to 180, as some unknown radian measure is to 90 degrees. Got to get that x alone, so I'm going to multiply both sides by 90, multiply both sides by 90. That side will cancel, and now I have 90 pi over 180. I can reduce this. Both of those two numbers are divisible by 90, so I'm going to end up getting pi over 2. And we knew that because we figured that out logically, just using what we knew about these relationships earlier. But you should be using a proportion to do any of them that are a little more complicated than that. So I would like you guys, before you come into class tomorrow, to have completed turning these 4 degree measures into radians using this proportion.